Assalamualaikum and greeting. My name is HISHAM bin ASRI, number matric B0819101001. So I will present about the introduction. So let me introduce to you what is a graph. First, graph and chart can help individually understand information more easily. There are many various types of graph and chart that can be used to display data in different ways, and they are frequently used in business. It's important to understand the many types of graph and chart so you can select the ideal one for presenting your data, especially when giving professional presentations. For second, graph and chart are frequently used to show trend, patterns, and relationship between collection of data. Certain type of data may benefit from graph, while another may benefit from chart. The chart of or graph you use will frequently be determined by the important detail you want another to take away from your data.
Assalamualaikum, my name is MUIZZ AKRAM bin SAPIE. My matric number is B0819104222. I'm gonna explain about the graph coloring. The definition of graph coloring is a proper coloring of a graph is an assignment of colors to the vertices of graph such that adjacent vertices are colored differently. It is possible that if we have n numbers of vertices, we can have n number of colors that we use to color the vertices. However, we typically want to use the least number of colors since it is possible to have repetition of color in the same graph. That happens because not all vertices are adjacent to each other makes the same color can be used again. And the smallest number of color in a coloring of graph G is called the chromatic number of G. This is example 1. In the example 1, we divide into 3 examples, which as we can see in the example 1.0, we assign different color to each vertices since the rule of each vertices cannot be the same color as the color that adjacent vertices have. Although such rule exists, but we can color the side vertices the same color since it separate from each other by the red vertices like example 1.1. And in example 1.2, there is a line that connect those two vertices to the first vertices. This is why they cannot be the same color since the line makes them adjacent to each other. This is example 2. As we can see in example 2.0, we assign different color to each vertices since the rule is each vertices cannot be the same color. Same as example 1.1, we can color the other side vertices the same color since it is not touched from the same vertices of same color, which is in the example 2.0 we color A and Z blue. But if there are a line that connect those two side vertices in example 2, which is C and D, they cannot be the same color since the line makes them adjacent to each other. In addition, vertices of B and E in example 2.1 are the same color because it is not adjacent to each other. So that's why we color the same color. Thus, in example 2, the minimum coloring is 3, as we can see in example 2.1, which is red, blue, and purple. And we can color at most 6 by the number of vertices in the graph. As in example 2.1, we using 3 color, which is the minimum possible for the graph, as we can say it 3 coloring or minimum coloring. Therefore, the chromatic number of this graph is 3, or in other words, 3 chromatic. Thank you.
Assalamualaikum and hi. My name is MUHAMAD. So in this part I will explain about the history of Dijkstra algorithm. Edgar W. Dijkstra biography. He was born on 11 May 1930, Rotterdam, Netherlands, and died on 6 August 2002 at age 72. He was a Dutch computer scientist who developed the paradigm of structured programming for writing computer programs. Dijkstra earned his PhD in 1959 from Amsterdam Mathematical Center. From 1963 to 1973, he taught at the Technical University of Eindhoven. From 1973 to 1984, he worked at Bureau Corporation, and from 1984 to 2000, he taught computer science at University of Texas at Austin. The history of Dijkstra algorithm. He is best known for his 1959 solution to the graph theory problem of the shortest path between two nodes of a network, devised in 20 minutes while he and his fiancée Maria Dibetz were sitting in a cafe. Even today, the Dijkstra algorithm is used to find the quickest route between 2 points, such as in the routing of communication networks and in flight planning. In 1960, he and Dutch computer scientist Jaap A. Zonneveld created the first ALGOL-60 compiler. As a result of his research on mutual exclusion in communications, he proposed the concept of computer semaphores in 1968. Application of Dijkstra algorithm in real life. Dijkstra algorithm has several real-world use cases, some of which are as follows. The first one is digital mapping service in Google Maps. Because there are multiple routes or paths connecting them, the shortest path algorithm is used to find the minimum distance between 2 points along the path. And the last one is flighting agenda. For example, a person needs software to create a customer flight schedule. The agent has full access to all airports and flights. Flights have a departure and arrival time in addition to a flight number. The agent wants to know the destination's earliest arrival time given an origin airport and start time. This algorithm is used there.
Hello, my name is Muhammad bin SALMI. My metric number is B018100067, and today I will be explaining about explanation and an example of Dijkstra algorithm. First, how Dijkstra algorithm work. Dijkstra algorithm choose the lowest total path weight from starting point until the current point. At the current point, we will calculate the total weight if we use the path for all the possible paths that adjacent to the current point. Then, we will take the lowest weight value, hence obtaining the lowest or shortest path possible for the graph. Next, let's take a look at this question. Find the shortest route from A to Z using Dijkstra algorithm for the following graph. So the question asks us to find the shortest path, aka the lowest total weight from A to Z. So how to do this question using Dijkstra algorithm? First, let's take a look at the solution. So here you can see this is the table that use Dijkstra algorithm. This table consists of iteration, how many loop already we do. This is the point from A to Z. This is the what point we choose at that iteration, and this is the set, what point that we are already choose. So on first iteration, it's obviously we're going to choose the starting point, which is A, because it has 0, the lowest possible path. And then with respect to A, we can see all the possible path, which is from A to C, which is 2, so we put 2 here. From A to B, which is 4, we put 4 here. From A to D is unknown, so we put infinity. Same to E, infinity, and same to the Z, also infinity. So we choose A, set A. Next, on the second iteration, it's going to look at the lowest possible path, which is 2. So we choose C. As you can see just now, Dijkstra algorithm is going to try to calculate both from A to B and A to C, and then Dijkstra algorithm will choose the lowest path, which is 2, C. So A, C. And then we are going to calculate all other points with respect to C from starting point A. So B is 2 plus 1, we get 3. And then from C to D, C to D, 2 plus 8 equal to 10. And then from C to E, 2 plus 10 equal to 12. From C to Z, it's unknown, so we put infinity, and then we choose C, and then the set is AC. Next, on the third iteration, we are going to choose the lowest possible path again. So 3 is choose, which is B. So now we are going to calculate other point with respect to B, but fortunately B only adjacent to A and D, but since A is already be used at the starting point, the only possible path is D, which is 8, because 2 plus 1 plus 5 equal to 8. Then from D, Dijkstra algorithm are going to do the same thing, which is we'll try to calculate both points that adjacent to it, which is E and Z, and choose the lowest path. Now we are going to calculate all other points with respect to D. So from D to E, 2 plus 1 plus 5 plus 2, we get 10. And from D to Z, 2 plus 1 plus 5 plus 6 equal to 14. On the next iteration, we are going to choose also the lowest path, which is 10, E. So we eliminate Z. So we are going to calculate other point that adjacent to E. So the only other point that adjacent to E that doesn't be used already is Z. So we are going to calculate 2 plus 1 plus 5 plus 2 plus 3 equal to 13. So on the last iteration, iteration 6, we are going to choose the lowest number, and the only number that's left between 14 and 13 is the lowest number. So we are going to choose 13, which is at the point Z. So in conclusion, the shortest path from A to Z is A, C, B, D, E, and Z, where the length is 13. 2 plus 1 plus 5 plus 2 plus 3 equal to 13. So as you can see here, Dijkstra algorithm will try to use all the path, but it will calculate the shortest path possible at the current point. So as you can see just now, we choose AC, AB. Since AC is lower than AB, then it will choose AC. Same goes to C, B, C, D, C, E. Since CB is the lowest number, we choose CB. That's why using Dijkstra algorithm, it is possible to calculate the shortest path that we desire. I think that's all from me. Thank you.
For the conclusion, finally, we can conclude that a graph is a visually representation or diagram that represents data or values in an ordered manner in mathematics. The relationship between two or more objects is frequently shown by the point on the graph. For example, we can use a graph to describe the data below, which Show the kind and number of school supply used by people in a class. We start by counting each supply and arranging the data in a table in a methodical way using specific colors. Visually, representation helps us to understand data quickly. When you show an effective graph or chart, your report or presentation gains clarity and authority.
That's all from us. Thank you.